everyone, my name is Morgan, and today I'm going to talk to you about spaghettification. Spaghettification, simply put, is theorized to be the vertical stretching and horizontal compression of an object, squeezing it into a long, thin shape. The term was created when astrophysicist Stephen Hawking described what would happen to an object approaching a massive object, such as a neutron star or a black hole. A black hole is a region of space having a gravitational field so intense that nothing can escape. No matter, not even light. They are the remains of a massive body shrinking down on itself from extreme gravitational forces. If you had a bed sheet stretched tightly, and a bowling ball, a tennis ball, and a marble placed on it, each object would stretch the fabric to a certain degree, relative to the size and density of the object. The stretch in the fabric is what the gravity of an object in space looks like. A black hole's density is so great that the gravitational pull is much stronger than any other object. Its gravitational field is extremely expansive, and objects can actually orbit at a safe distance. But there is a boundary between safety and the point of no return. That boundary is called the event horizon. Any matter or light that falls past the event horizon can never escape. Now imagine an astronaut floating through space, just enjoying the view. If they were to drift towards a black hole, it is theorized that a very strange thing would occur. They would begin to experience tensile and tidal forces. First, I'll explain tensile forces. In physics, tension is the opposite of compression. It is used to describe force exerted by the ends of a three-dimensional continuous material. Think of a bowling ball at the end of a string pulling down with a great force. Except in this case, the black hole is the bowling ball and the astronaut is the string. The more force that is exerted, the more stretched the string, or the astronaut, becomes. But because of the intense density of a black hole, gravity tries to pull in one direction and squeeze in another, essentially pulling the astronaut downward endlessly. The astronaut is also experiencing tidal forces, which are secondary gravity effects. These gravity tides are not constant across the black hole, meaning that the nearest point of an object is attracted more strongly than the farthest point of an object. For example, because of a gravitational gradient, a person would feel their feet being affected before their head. They would be vertically stretched, but they would also be horizontally compressed at the same rate, balancing the tension, meaning that they would not experience any change in volume. Imagine a glob of dough. If you pulled apart the dough, it would stretch and become thinner at the center. But at the event horizon, the dough would maintain the same volume throughout and continue to be stretched and compressed at the same time, creating a continuous spaghetti noodle. That is spaghettification. As I've grown, I've learned that space is not the final frontier. There's nothing final about discoveries. Curiosity leads to ideas, which lead to theories, which start to cultivate our learning. Though spaghettification is still just a theory, exploring these ideas is like traveling a hallway filled with endless doors. You never know what you'll find behind the next one. Discoveries are what open the doors up into the future of education.